This is the video solution to number 1 of the pre-check problem set as a pre-test question. This is from set number 1. To play skee ball, a ball is pushed for half a meter from rest. The .015 kilogram ball hits a bump and bounces up. At its highest point, the ball is traveling horizontally at 1.5 meters per second and is 0.7 meters high. How much force was used to start the ball rolling? Only use energy methods to solve. So at the very beginning, the ball is at rest right here. So I know what the velocity is there. That's going to be 0. And it's pushed across some distance here for half a meter. That's the distance. And I'm looking for the force. So when using energy methods in this, my force is going to add energy to the system. And I need my 2 locations to compare. One is going to be at the very beginning, where I know what the velocity is and the height. And then over here is the next place where I know the velocity and the height. So that'll be my next location that I'm going to compare. So I'll say sum of the energy, let's call it start, plus the work done, let's call it push. That's the force that I'm applying. So I know I'm going to add it because the force and the distance go in the same direction. And that's going to equal the sum of the energy, let's just say H equals 0.75 meters. Next, I'm going to describe what the summation of the energies are. So that'll be the kinetic energy plus the potential energy plus the work done by the push equals the kinetic energy plus the potential energy. So I'll go through my questions to figure out which of these energies I really have. At the start, is it moving? Well, let's see. Oh, it starts from rest, so that's going to go to 0. Is it above the other location? No, it's not, so that's 0. On the right, is it moving? Yes, 1.5 meters per second. Does it have height? Yes, 0.75 meters. So now let's put in some more numbers. So this means that force of the push times D is equal to 1/2 mv squared plus mgh. All right, let's throw in my numbers. So I'm looking for the force. That's going to be my unknown. Force, distance is 1/2 meter, 0.50 meters. And that equals 1/2 the mass, 0.0150 kilograms, times velocity squared. Oops. Let me replace that with the right number. There we go. With 1.5 meters per second squared plus mgh. That's going to be 0.0150 kilograms times 9.80 meters per second squared. That's my height, 0.75 meters. Whew, barely got that in. Now let me rewrite that without the units. Since they're all in the same unit system, I'll suppress the units just so I can see what's going on. So the force is equal to, force times distance. Let me redo that for a second. Force times 0.50 equals 1/2 0.015 times 1.5 squared plus 0.0150 times 9.80 times 0.75. Yeah, a little bit easier. So now what I'm going to do is I'm going to simplify my expressions. Remember, math expressions are separated by equal signs, pluses, and minuses. So when I look at this, I can see I've got an expression over here, expression here, and expression there. So I'm going to go ahead and simplify them. The first one I really can't simplify. 0.50 times f equals, the first one I can, and when I do the math, I get 0.016875 plus 0.11025. Now add the 2 on the right up. So 0.50 times f equals, when I add them, I get 0.127125. So to get f all by itself, I'll divide both sides by 0.5. Remember, whatever you do to one side, you got to do to both sides. And that leaves my force to be equal to 0.254 newtons.